We're recording now, so we're learning about ellipses. And we already showed you.
We're recording now?
Yep, we're recording now. So we already learned about ellipses and how they're generated. So these, from these 2 points called foci, an ellipse is a set of all points that are the sum of the distance from here, from this point to a curve, and from this point to another point is always the same. Okay? Ellipse is a set of all points in a plane, the sum of whose distances from two fixed points called foci is a constant. Standard form of an ellipse, okay, is this x minus h squared, where hk makes the center of the ellipse, and a and b are called the major and minor axes of the ellipse. Okay, so this one here, A is always bigger than B for ellipses. That's not true for hyperbolas, which we'll talk about on Friday, but A is always bigger than B. So, and A is the distance from here to here. Okay, so it's the distance from the center out and out along this is called the major axis to the outside. What's wrong?
That's what A is?
Yep. A is the distance from the center to the widest part of the ellipse. Okay? And B is the distance from the center to the smallest part of the ellipse. Okay? If A comes first, or if X comes first in the ellipse, it's what I call a horizontal ellipse. It's going this way. But if B comes first, meaning B is smaller than A, then A is the bigger number, and it's going this way. Okay?
Wait, you just said if B is smaller than A, but B is always smaller.
I said if B is smaller than A? No. If B, yeah. But if B comes first. So if B is under the X, then your ellipse is going this way. So if the smaller number is under the X, then it's going this way. If your smaller number is under the Y, then it's going this way. A is 2A is equal to the length of the major axis. Length of major axis. Major axis, and 2B is the length. The major axis is the axis in the direction, the long way. Okay, it's the distance from one point to the other point. So this would be 2A in this case. This would be 2A in this case. 2B, or B, would be, this would be B, so from here to here would be 2B. In this case, this is 2B, right? That's the length of the minor axis. Okay? The foci are always on the major axis. Always on the major axis. Okay, so they're always on the same line that A is on. And the foci are here and here. And in this case, in all cases, the distance from the center to the foci is C. Okay? So C is the distance equals the distance from, or the absolute value of C, I should say. The absolute value of C is the distance from, actually C is always fine. C is the distance from the center to foci. Okay? So then you can do all this stuff. And the other thing that you have to know is that it's kind of like the opposite of the Pythagorean theorem, if you think about it. These are related by the equation c squared equals a squared minus b squared. Not like the Pythagorean theorem, which is a squared plus b squared, right? So, and then major vertices, and again, like I did with parallels, I think it's easiest if you draw a picture for it rather than memorize a whole bunch of formulas, all right? And that's the way I've done it. in my mathematical career. And it's always served me well, all right? So graph the ellipse. So this one, since there's no HK, this one is centered. We need a different color than red. Red's not very good.
Purple.
Purple, okay. So this one's centered at the origin. And this is a squared, so that must mean that A is what?
4.
A is 4, and B is 3. Have you guys done this before?
Last year.
Maybe last year. Okay. And standard form, this is already in standard form, so you don't have to worry about that. This, so the center is at 0, 0. And then the vertices, since A is 4, you're going to go over 4, 1, 2, 3, 4, out that way. And then you're going to go back 4, 1, 2, 3, 4, back that way. So that's A, distance from there to there. And B is 3, and that one's smaller than 4, right? 3 and 3. And so the vertices are at plus or minus 4, 0, right? And at 0, plus or minus 3. That's actually 4 points, which I just drew. And then you can draw in a picture of that ellipse. I wish I had an ellipse drawing tool.
This reminds me of how horrible I have to draw ellipses.
Okay, but I wonder if I could take a circle and stretch it. Oh! Let's see if I can do it with this tool.
No, try. You have to start at one.
You have to start at one of the endpoints.
I don't think that's gonna work.
All right, you just be quiet. I'm gonna get this. There I go. If I start at one of the
Start at the
endpoints.
end point, though.
You're gonna have to start at a corner.
Yeah, start at intersection.
Wait, let me just do one more
Actually,
try.
split that up. 3 -2.
1 minute. Let's start down here. Here?
No, no, it's up.
Go
below.
ahead.
Diagonally 1.
Oh.
Oh.
Hopefully, Gangnam style.
Oh,
That's pretty good.
Gangnam style. Okay. So there's my ellipse. Now to find my foci, okay, I just apply this equation. All right. So I know what a squared is. A squared is right there. Okay. And so I know that c squared is going to be equal to 16 minus 9. 16 minus 9. So c squared equals 7. So c is equal to plus or minus the square root of 7, which is, that's got to be 2 point something, right? So about here and here are 1, 2 point something. So those are my foci. We'll call this focus 1, focus 2. And so those are going to be at plus or minus square root of 7, 0. And the foci don't really help you graph the ellipse. They do tell you like the eccentricity of the ellipse. So if their eccentricity is kind of a measure of how stretched out it is. So the foci are way out here. We learned by that little demo I did. It's going to be a very stretched out ellipse, right? And if the foci are very close to each other, it's going to be a very circular kind of ellipse. Any questions on that? Easy so far? Yeah. All right. So then now we have to discuss the equation. So you say, oh, that's a very nice equation, don't you think so? Oh, yeah, that's looking pretty good. Good. What do you think? Okay, no, that's not what they mean by discuss. What they mean is find all the foci center, all that kind of stuff. So this one, a little bit tricky because all of these have to have a 1 on this side. So the first thing I have to do is get this into standard form. So how would I get this one into standard form first? Divide everything by 9. Very good. So I'm going to divide by 9, divide by 9, divide by 9. And I get x squared actually over 1 plus y squared over 9 equals 1. And now it's in standard form. And so that means that the center has to be where again? 0, 0, because there's no HK kind of thing. Okay? And then the vertices, the A, this is not A, right? This is A in this case. So A is what? what square root of 9, which is 3. And b is 1.
Wait, why is that not?
Because a is always bigger than b. Okay? So if the bigger number is underneath the y squared, then it goes with the a. Okay? So the bigger number is always a. Yes,
Why
Jeff?
is the center 0?
Because there's no HK. If they were like this, then the center would be. Okay? So now I can kind of sketch this. Now notice that A is 3, so the bigger axis is going vertically. All right? So this is what I would call a vertical ellipse. So it's this way 3, and then it's down 3, and then it's out 1 on either side. So this is kind of a squishy looking ellipse. Let's see if I could do this again. Oh. Oh, I didn't want that last little goofy thing. Okay. So that's what that ellipse would look like. And then again, we can find the vertices, right? Vertices are at 0, plus or minus 3. And then at plus or minus 1, 0. And then the foci, you're going to do a squared minus b squared equals c squared. So 9 minus 1 equals c squared. So c squared equals 8. So c is equal to plus or minus the square root of 8, which can be written as 2 root of 2. 2 root of 2, which is about 2.8, because I know that root of 2 is 1.414. So it's about 2.8, so somewhere about here somewhere. Very close, right? Because this is kind of a stretchy ellipse. So those foci are going to be 0, comma, plus or minus root of 2. 2 root 2. Root of 2, 2.
Isn't it 2 root 2?
2 root of 2. 2 root of 2. Sorry. 2 root of 2. 2. Hooty hooty hoo. Yay! Scooby Dooby. Oh, sorry. I shouldn't do this on my video. All right. Okay. So now, what? Rest. Okay. That was Scooby Doo.
No, it wasn't.
Okay. Anyway, so standard form. This one is already in standard form. Okay. We can find the center. Now the center is different in this one, right? So it is at 2, negative 1. All right. And then A is what? No.
3.
3A is 3, so this is going to be a vertically going ellipse, and B is 2, right? And then, so first I would sketch it, and then try to find the vertices. So we know that the center is at 2, 1, so I'm going to go over 2 and up 1 and call that my center. Okay? From that point to find the
Wait,
I
down one.
I do that. Over 2 and down 1. Okay, someone's way here. Okay? 2 down 1. And then I am going to go up 3 from that point. 1, 2, 3, which puts me at 2, 2, 2. Is that right? 2, 2. Yeah. 2, 2. And then I'm going to go down 3 from that point. 1, 2, 3, which puts me at, so that's one vertice is at 2, comma 2, and another one is at 2, comma what? Subtract 3 from negative
4.
1. Negative 4. And then I have to find the other 2 vertices, which are over 2 from here. Right? So that point would be 4, 2. Right?
4 negative.
4, negative 1, I'm sorry. 4, negative 1. And the other one would be back 2 from over there. Would put me at 4. Wouldn't it put me at 4, 0?
No, it's 0, -1.
0, sorry, I'm sorry, 0, -1, just seeing if you guys are awake here, okay? And then, using my special ellipse drawing tool, I can start here and draw that bad boy in there. Wow, I keep getting that extra little circle.
Where does it come from?
What?
Where does it come from?
I don't know, outer space. Now, to find the foci, okay, to find the foci, again, I just do a squared minus b squared, so that'd be 9 minus 4 equals c squared. So c ends up being plus or minus the square root of
5.
5. Okay, so to find the foci, to write them exactly, one foci would be, since the center is at 2.
So would it just be 2 plus
2
or
negatives,
minus?
yep, it'd be 2 plus
Plus or minus.
root of 5, comma, -1. So I'm just adding root of 5 to here, right? No, that's wrong.
No, it's
That's
just
wrong.
right
Because the
here.
foci are here and here, right? Root of 5 is about 2 points on them. So here and here. Okay? Wait, more like up here.
It's
down.
2.
So it'd be 2 minus 2, comma, -1 plus root of 5. And then again at 2, comma, -1 minus root of 5. That would be my 2 foci. Right? Because this is a point of 2, -1, so I need to add root of 5 to get that focus. And then I need to subtract root of 5 to get that focus.
If we just said plus or minus root of 5, like 2 plus or minus root of 5 on a test, would you accept that as an answer?
2, comma, -1 plus or minus root of 5.
Yeah.
Yeah, that'd be it.
Oh wait.
Yeah. So you could write it
Why
as
did
2,
you write the -1
comma, negative,
Because that's
because
where you're
it's,
starting.
you start at -1 and then you add
Focus.
root of 5 or you subtract
Ah.
root of 5. Okay? All right. More stuff. Completing the square. I know how you like completing the square, don't you? Good? So look, so in this one, did I unpause it? Did I unpause?
Yeah.
Okay. Oh, it says recording, so we're recording. So with this one, to complete the square, you need to complete the square on both the x and y parts. Now this is an especially kind of tricky one. So let me think a minute. Okay, I think I got it. So the first thing I would do, let's grab a big piece of paper because this might take some work here.
Did you not give us enough room for this?
For this one, I don't know. We'll see. So, well,
No,
I don't know what that
fake
thing
news.
is. So, let's try. So the first thing I want to do is bring everything onto the right side. Well, not everything. Bring the constants over to the other side. So, and the other thing I want to do is group my x squared, my x parts, and my y parts together. Minus 8x plus y squared plus 4y. And I'm going to bring this -4 over onto this side. See what I did? Okay. Now, before I complete the square, I can't really complete the square if I have a 4 in front of this. It makes it more tricky. So what I'm going to do out of the x part, I'm going to factor out a 4. X squared minus what?
2x.
Minus 2x plus y squared plus 4y equals -4. So now I do the completing the square part. So what I'm going to do is 4 times, what's at half of -2?
1.
X, so I'm going to go x minus 1 squared, and we'll worry about what we had. Plus half of 4y
2.
plus 2 squared equals -4 plus something else.
Plus 2.
Plus,
4.
nah. So I've added 1 squared times 4. So how much have I added? I've added 4 when I did this. Because 1 squared, right? Times 4, because I factored out this 4. Here, how much have I added?
Just.
Just plain old 4, so I need to add a 4 over to here. Follow? Okay? So now,
Wait, where did you get the 4 in the middle?
where did this 4?
Yeah.
Because if I FOIL this out, right, it'd give me x squared minus 2x plus 1, right? But I'm multiplying all that by 4.
Oh, okay.
So I've added actually 4 times that. So that's tricky. Now I simplify. So I get 4 times x minus 1 squared. There's a lot of steps here. Minus 1 squared plus y plus 2 squared equals 4. And now I need to get a 1 on this side, which actually works out pretty well for us. How do I turn that into a 1? Divide by 4. Okay? Divide everything by 4. Divide that by 4. And then I get, this goes away, right? And turns into a 1. So now in standard form, this becomes x minus 1 quantity squared over 1 plus y plus 2 quantity squared over 4 equals 1. Uh-oh. Time to go. No, that was just my phone. So that means that A is
2.
2 and B is 1. And the center is at 1 comma negative 2. All right? And then you could graph the rest, right? Do you want me to keep going?
Not
Okay.
particularly.
Center is at 1 comma 2. Okay. So if I go, it's a vertical one. So if I go 2 up from there, and if I go 2 down from there, 1, 2. Okay. So, right? I did that. Yes, sir. I didn't graph 1, negative 2 right, did I? 1, negative 2. So I'm going to go up 2 and down 2. And I'm going to go over 1 and over 1. So those are your 4 points of your ellipse. Hold on. And then you guys could. There, I did it without drawing that extra circle. There it is. And then what? Jeff?
Oh, yeah.
Okay.
You got it.
You got it.
Yeah.
Okay, so that's how you do that one. Then you can find the focus just going a squared plus b squared and adding it to the vertical axis. So let's just look at this word problem, just see what they're talking about real quick, and then I'll be done for the day. A Whispering Gallery Museum area 47.3, beyond from the center to the foci is 20.3. So what I would do is draw a picture of this thing real quick. Okay? Here it is. It looks like this. And the Whispering Gallery Museum is 47.3 feet long. So if I go straight across, okay, it's 47.3 feet. All right? And the distance from the center of the room to the foci is 20.3. So from here to here, and I'm just assuming that it's oriented this way. So this has got to be 20.3, and this from here to here would have to be half of 47.3. What's that going to be? 23.65, is that right? I think. Is that right, Rana? What?
Isn't the entire thing 47.3?
The entire thing is 47.3, so from the center out to here would be half of that, right?
Yeah, which is 23.65.
23.65. Okay? So then it says, find an equation that describes the shape of the room. Well, I know A, and I know C. Now I have to find B. So you know that A squared minus B squared equals C squared. So I just plug in. I get 23.5 squared minus b squared equals 20.3 squared. Yes? And then you have to do that. You can do that for me. So you get that b squared equals 23.5 squared minus 20.3.
Wasn't it 23.65?
Whoops. 23.65, sorry. 65. So you do that on your calculator and you'll get b squared, right? Can you do that, Rana? 23.65 squared minus 20.3 squared? What do you get? 104, that's b squared? Couldn't be. No, b squared. 23 couldn't be that big.
Break out your hand.
Choose b squared, not square root.
Is that b squared? No, it couldn't be.
Oh yeah, so b squared is what?
147.
147.23, so what's the square root of that?
12.
So b is 12 point what?
05.
12.05. So they say, how high is the room as its center? Right there, it's 12.05.
Well, that was just a guess.
Oh, that was just a guess?
It's a pretty good guess, though.
12 point what? 13.
Yeah.
Sam, you're up. That was a good guess, though.
I know.
What is the area? And then to find the area, they tell you that this is the area formula for an ellipse. So you just plug in pi times a times b. Okay? And that's it. And remember, you heard it here on Mr. Leader's Condoms Stop YouTube channel. Okay.
Out of the house.
Wait.